All right, this video is going to give you an example of how to use the power reduction formulas. It's specifically here how to take cosine to the fourth and go ahead and make sure that it has powers of sine and cosine not greater than 1. So one thing to make sure we remember is cosine to the fourth would be potentially also written like this. And we could write that as cosine x squared and then squared. So let's go ahead and substitute this piece inside. So cosine of cosine squared is 1 plus cosine 2 theta all over 2 squared. And I'm going to choose to write that as 1/2 plus 1/2 cosine of 2 theta squared. So all I did was just divide up this half piece and kind of split up that fraction. So this is going to be 1/2 times this other piece multiplied by itself. So let's maybe make sure we do that correctly. That's going to be 1/4, 1/4 cosine, 1/4 cosine, 1/4 cosine squared. So this expansion is going to be 1/4 plus, I have 2 of these, so 1/2 cosine of 2 theta. Okay, that's in power of cosine, plus 1/4 cosine squared of 2 theta. Well, I need to make this substitution again in order to make sure that I only have cosines in the first degree. So I'm going to plug back in 1 plus cosine. Now be careful. This is of 2 theta, so 2 times 2 would give me 4 theta all over 2. And that would end up being our final answer. You could distribute in here if you wanted to. And we would get what, 1/8 plus 1/4 cosine 4 theta. And then plus this down here. All right, and then we could also do this with identities. So show that sine cubed is equal to this right-hand side. So let's go ahead and remind ourselves again, this would be sine of 2x cubed. And so one way that we could write that is sine of 2x times sine of 2x squared. Let's look at what sine squared is equal to. Sine squared is equal to 1 minus cosine 2 theta over 2. So let's go ahead and leave that sine of 2x there. And we're going to have 1 minus cosine. Now, again, we got to be careful because this is sine of 2x. So I'm going to have a 4x, a 2 times 2x on the inside. Sorry, no squared there because we're substituting this piece here, right? This is equal to sine of 2x squared. All right, and then we just need to manipulate to look like this. So if I were to factor this 1/2 out here completely, I would have 1/2 sine of 2x on the outside, and then I would have 1 minus cosine of 4x on the inside, and that ends up checking out with our right-hand side.